Which sheet are we on?
All right, listen up. We are going to continue with the unit circle. And you should have the sheet in front of you that's horizontal, and we've already put the radians and degrees on it. Okay? That's as far as we got the other day. And we started talking about some special triangles. And the special triangles that you have worked with before, if I can fit it over here, would be one that looks like this, one that looks like this. Make it so it's on there. This may take a minute. My triangle, I know, my triangle skills, I'm losing it. All right, so we have this. There we go, now I'm good. All right, so we have a triangle that looks like this. It is a 30, 60, 90 triangle, where this is the 30-degree angle, this is the right angle, and this is the 60-degree angle. Okay? And we talked about this the other day. You have dealt with special triangles, and when the hypotenuse here is 1, like the radius of our circle, then the side opposite 30 will end up being 1/2, because in a 30, 60, 90 triangle, the side opposite 30 is half the hypotenuse. And then the side opposite 60, which is over here, ends up being the 1/2 times root 3. So this is root 3 over 2. All right. Well, if you look at your unit circle in front of you, I have a 30-degree angle here. Yes? Yeah. Okay. And if I don't write anything yet, just watch first. If I drop a vertical down from where that 30-degree angle radius hits the unit circle, then I have my 30, 60, 90 triangle right there. Correct? Here's 30 degrees. The 60 degrees is up here, and that's 90 degrees, yes? And the hypotenuse is what length on the unit circle? 1. Well, that means, what is the length from here over to this line? Look at my triangle. Root 3 over 2. And what is the distance from here up to the circle? Exactly. So the coordinates of this point right here, and you have a space for it on your, it's parentheses on your sheet. So the coordinates of that point will be root 3 over 2, don't write yet, and 1/2. Everybody good with that? All right, well, I see 3 other places where I have that same triangle. I've got one, nope, not yet. I've got one here, correct? I've got one here. And I have one here. These are all 30, 60, 90 triangles with the same orientation, or the same x and y coordinates, just in different quadrants, yes? So what would be the coordinate of this point here? Negative root 3 over 2, 1/2. Very nice. And then this one down here? Very nice. And then this one? Root 3 over 2. Now, one color. Do it nicely. You can draw in those 4 triangles and label the coordinates with that color. It's only the ones that make the 30-degree angle with the horizontal. So we're only doing this one, that one, this one, and this one. Think about you go right, so that's positive, and then left. I said that, that's down. The Y value is negative. Sorry, it's not on there. That's why you're pointing. I got it.
We do draw the triangles too.
Yeah. Okay, so now we're going to move on, and what we're going to do is get the coordinates of every point where these lines are hitting our circle. And we're going to do it with special triangles and what we already know about our coordinate system. Okay, so the next triangle I want to talk about, I will put it over here. So it's basically the same triangle, but it is split. So we've got a line this way, a short line on the bottom, long line here, and up like that. So here's our 90. This time, our 60-degree angle is here, and our 30-degree angle is up here. What's the hypotenuse of this one? Still 1. So what is the length of this side? That's the 1/2. And what is the length of this side? Good. √3 over 2. So if we choose a different color, I am going to go, please be careful, here's where you'll make a mistake. We're not doing the pi-4 one right now. 60 degrees is pi-3, right? So we're going up to this line, the top of the diagonal lines in each of your quadrants, and that's where we're going to drop down our vertical.
So from the pi-3 downward.
So from where the pi-3 hits, hits our circle, we will drop down and make our right triangle. Okay, so we're doing it from each of the pi-3 ones. So all 4. We'll get all 4 of them. We're going to draw in all 4. You bet.
I'm sorry.
I wonder by whom.
I don't know.
All the way down. You're going to hit the degree. Quiet, please. Okay. I'll come check, Rachel. 1 sec.
So I know it.
You know we did. I did know me. Becca? So these are from the other day. All right. I'll have to get okay, you're just going to have to make quiet, please. Push. That's right. Not put the coordinates in yet. Here we go. All right. So I'm going to back up to my pen, and I'm going to use the red pen to show where on this one. So since it is still a 30, 60, 90 triangle, this time I'm going to the right how much? 1/2, and up how much? Very good, √3 over 2. So at your pi-3 where you have your parentheses, we are going right 1/2 and up √3 over 2. So now the signs will change, but make sure you're hitting the right one. We should be at 2 pi-3 with a 120-degree angle, and here we're going to have what? Let's say it before we write it.
-1/2, √3.
That is correct. -1/2, positive √3 over 2. Is everyone okay with where we're getting these positives and negatives? Just how we move on the coordinate axis. If I'm going left, that is a negative value. So I go -1/2, and then I go up. Up is positive, so we have positive √3 over 2. Okay? Quiet, please. Yes.
So how do you get the 1/2 square √3 over 2?
Okay. So it's the same triangle that we used here.
Yeah, I just when you get it from that.
Well, we actually are using this one. So what I'm saying is it's this triangle rotated to here, okay? And the hypotenuse is 1, yes, because it's the radius of the circle. And our special triangles, we developed our rules for our special triangles in geometry.
Yeah.
So the side opposite 30 is always half side high. And notice that's on the horizontal. So that means here, that is 1/2. And then the vertical is the side opposite 60, which is root 3 times this number. That's where the root 3 over 2 comes from. And so that is our vertical here. So we go right 1/2 and up root 3 over 2. Yep? Yeah. Okay. All right. And so our signs will change depending on which quadrant we're in. So now we're down here at 4 5/3. You guys have more room on your sheet than I have on my screen. So what are the units for, what are the coordinates of this one going to be?
-1/2.
Very nice. And then 5 5/3?
It will be 1/2, negative root 3 over 2.
Perfect. Sorry, mine is so crowded, but hopefully you're okay with it. How do you? All right, it looks like our last special triangle, 45, 45, 90. I'm going to see if I can fit it up in the upper left of mine. You still have this? Quiet, please. Okay. So, our last one is the 45, 45, 90. And if you recall, this one's going by hand here. With a 45, 45, 90, these two legs are the same length. Well, thank you, man. All right, our hypotenuse is still going to be 1. And with 45, 45, 90, basically we're doing 8 squared plus 8 squared is equal to 1. And we solved this on Friday, and we said that the way that we'll write this on the unit circle is root 2 over 2 and root 2 over 2. They're the same length. So now we want to go to our pi over 4 and start dropping down our lines. I'm going to change my line color. Blue. Maybe it'll be yellow. All right, listen. So at pi 4, I am dropping my vertical down to the x-axis. And at 3 pi 4, 5 pi 4, and 7 pi 4. Now, if those are likely the same length, how far am I going to the right? How far? We get to this point right here. Root 2 over 2. So I'm going over to the right root 2 over 2 and then up root 2 over 2. So our coordinates are root 2 over 2, comma, root 2 over 2. Let's finish these 4. Yes. All right. So we have this point right here. Quiet, please. This one will be negative root 2 over 2 and root 2 over 2. This one down here will be what? Good. Those negatives. And then finally, 7 pi 4 will be positive root 2 over 2, comma, negative root 2 over 2. Very busy page, but that's everything we need on our unit circle.
One is better than 45, 45, right?
Yes.
Or you have to memorize those.
All right. So, yes.
It was like for like the pi, like 180 degrees.
Oh, yes. That we have an idea, right?
Yeah.
Yep. We're going to do it right now. I'll do that in blue. So we have not given the coordinates for each of these. Our horizontal and vertical ones. Quiet, please. Now let's remember, this is a circle with radius of 1. So what are the coordinates of this point? What is it? Not 0, the x first. 1 comma. Yeah. So this is 1 comma 0. And the one vertically up? 0 comma 1. The one to the left? -1, 0. And the one down at the bottom? 0, -1.
Wait, what was it?
0, 1. All right, I've got it all on there. I'm leaving it up here. I'm not going to rush you. Just finish it up. If you need clarification, call me over.
You know how cool that was?
All right, so on the unit circle, the cosine of the angle is the x-coordinate, the sine of the angle is the y-coordinate, and the tangent of the angle, you put the y over the x. So the first problem on here is cosine of what? Cosine of pi over 3. So the pi over 3 angle is here, the cosine is the x, so what is that equal to? Done. Cosine of 6 degrees is 1/2.
Wait, no, I was not.
So, on the unit circle, the cosine of the angle you're interested in is the x. The sine of the angle you're interested in is the y. And the tangent is the y over x. So if I want cosine of pi thirds, I go up to the pi thirds line, out to the circle. The cosine is the x-coordinate, and that is 1/2. Done.
Oh, my God.
Just worry about this right now. We have it for tonight. All right. What's the second one? Number 2. Sine of 90 degrees. Go to the 90-degree angle. Look at the coordinate. The y-coordinate is sine of 90 is 1.
No, not.
That's so much.
It's just how important to the that.
Yes.
So we don't have to, all right, I was, my understanding is, you know, write that.
So, I will be letting you use your unit circle. Yes, now I may, listen up, I may on a no calculator portion have you find something like we did on the unit circle. But for all the sines, cosines, and tangents, you're using your unit circle. All your hard work pays off. All right, so what's the third one? Tangent of what?
Pi over.
Pi over 4. So, we go to pi over 4. Now, listen to me. I give you all the glorious hints about these things. Tangent though is the trickiest. You have to put the y over the x and reduce. But, any of the pi over 4s are lovely tangents. They're a form of 1, either positive or -1, because the y and the x are exactly the same. So, tangent of pi 4s will be 1. So we put root 2 over 2 over root 2 over 2, which is 1. Okay? All right. What is number 4?
It's 1/2.
Sine of 150? Go to 150, get the y value, that is 1/2. Yes. No, you're okay.
No, they haven't, forgotten to see.
All right, so I think you guys are good to go for a little bit. I'll take questions while you're working on it.